Hello, and thank you for joining us today for the Nuclear Innovation Alliance press briefing on the release of their new primer on advanced reactor technologies. The objective of today's conversation is to share information and insight with you about what is, admittedly, a complex and challenging topic. We're here to help, and that's why NIA has developed this primer. My name is Ben Finzel. I'm president of Renew PR, and I have the pleasure and privilege of supporting NIA on communications programs. Today, I'll serve as the moderator for this discussion with NIA staff and developers from two leading advanced nuclear innovators. Our participants today are NIA Executive Director Judy Greenwald, NIA Project Manager Dr. Patrick White, X-Energy Program Manager Harlan Bowers, and USNC Director of Technology Strategy Dr. Christian Rabidi. So yes, you are getting two doctors for the price of one today. Nice way to start back to school month. So to give you a sense of our agenda today, we're going to hear from NIA staff about what this primer is, and then we'll hear from two leading developers about the marketplace, their businesses, and their thoughts on technology development. We'll have time for questions after everyone's remarks, and you're welcome to start putting your questions in the chat box now so that we have some to start with, or you can choose to wait for the Q&A and ask your question directly. To be recognized at that time, simply use the raise hand feature or send us a message in the chat box to let us know you have a question. And please remember to include your name and outlet along with your question. And as a reminder, this is a press briefing, so we have lots of other folks from some of the companies on as well. Please do remember that we're going to limit questions to the reporters who are attending today so they can get the most value out of this and understand what they need to know about the primer. And I will do my best to call on folks in order when we do start the Q&A a little later in this program. We do want to get right into the conversation about the primer, so I'm going to wait to provide more detailed and flowery and exciting introductions for our two special guests. I'm going to start right away with NIA Executive Director Judy Greenwald. So Judy, over to you.
Thanks, Ben. Welcome, everyone. Thank you for joining us for this press briefing on the Nuclear Innovation Alliance's latest publication, Advanced Nuclear Reactor Technology, a Primer. For those of you who don't know us, NIA is a nonprofit, nonpartisan think and do tank, working to create the conditions for success for advanced nuclear energy as a climate solution. Through research, analysis, and education, we inform decarbonization and innovation policy. We've played a leading role in informing major federal legislation to reform advanced reactor licensing at the Nuclear Regulatory Commission and to build out the Department of Energy's nuclear innovation efforts. We also collaborate with stakeholders to coordinate advanced nuclear reactor advocacy in the United States. The NIA team created this primer as a guide for media, policymakers, stakeholders, and really anyone who wants to understand the rapidly evolving advanced nuclear energy space. It's intended as a 101 document to demystify advanced nuclear reactors and explain the characteristics of the most common types and leading designs. For some context, the commercial nuclear industry in the United States has over 60 years of experience in designing, constructing, and operating light water nuclear reactors. The conventional technology in use across the country is well understood by a host of players, scientists and engineers, of course, but also policymakers, journalists, academics, and other stakeholders. However, due to a host of emerging factors, especially growing concerns about climate change, shifting energy market demands, improved computing and engineering competencies, and heightened interest from financial investors, new advanced nuclear reactor designs are now increasingly viable, both technically and economically, with some in various stages of R&D and others being demonstrated within this decade. With the exception of a handful of hardworking policy wonks in DC, and a collection of engineers across the country, there are very few who can easily navigate this new landscape. It's our hope that as you write or consider stories on climate and energy, you'll consider NIA and this primer to be a resource, a place to start learning. So back to you, Ben.
Judy, thanks so much for that helpful perspective on why we're here today. Always good to start there. So now for a bit more detail on what's actually in the primer, we're going to hear from NIA's newest staff member, Dr. Patrick White. Patrick, take it away.
Great. Thanks so much, Ben. So at NIA, we see a real value in making information about advanced nuclear reactors accessible, chiefly because it really helps strengthen and contextualize everyone's understanding of the broader value proposition of advanced nuclear reactors. For example, in order to really appreciate that a microreactor might be able to power something like a remote Arctic outpost, It's first important to understand how that technology can run with minimal refueling using new types of fuel or new reactor designs. Now, nuclear energy can be intimidatingly complex. The science, the technology, and the jargon can make a lot of the discussions around nuclear energy indecipherable to most people, even those that have spent a lifetime in the energy sector. We believe that the primer provides clear and concise descriptions on key advanced nuclear energy topics to enable readers and reporters like yourselves to better understand and evaluate the technical discussions and claims that you might see about advanced reactors. And so to kind of dive into some technical topics and a few examples, one example of how we might be able to demystify nuclear energy using the primer is how we can highlight the implications of reactor coolants on the larger idea of what might an advanced nuclear reactor look like. So engineers and developers will often define their technology based on the method or material that's used to remove heat produced by fission reactions inside the reactor. The descriptions such as a water or gas-cooled reactor, sodium or molten salt reactors, or heat pipe reactors may seem simple, but actually have huge implications on the inherent design, use cases, and safety of different technologies. And you can actually tell a lot by a reactor just by knowing the coolant type. Let's think about gas reactors as an example. So when you hear that something's a gas reactor, a few things can immediately come to mind. The first is that it's probably going to be operated at high temperature. Gas reactors, unlike water-cooled reactors, aren't going to be limited based on what temperature their coolant boils. It's already a gas. And so as a result, they're really only limited by their materials and how far you can really push the design in that regard. So this facilitates the use of gas reactors in certain high temperature applications like process heat and hydrogen generation that historically we haven't been able to use nuclear technology. Gas reactors also are going to have a lower power density. This low power density means that it can be easier to cool the reactors after shutdown, and that some of the emergency cooling systems that have historically been needed and relied upon for light water reactors or conventional nuclear technology might not be needed. They can be designed to inherently cool themselves off without these emergency systems and make them even safer to operate than the existing fleet. Finally, gas reactors have what technology assessment experts refer to as a high technology readiness level. We have real operating experience with gas reactors, and so there are probably going to be fewer unknowns related to design and operation. While there are still going to be some design challenges and technology issues that we're going to work through, the technology is overall better characterized than some other advanced reactor types. And so you can get all this information just from the term, oh, it's a gas reactor. And these are some of the highlights and some of the insights that we believe the primer can help you with as you're starting to hear and discuss advanced reactor technology. Another example of a topic that's often kind of thrown around as jargon and actually has a lot of subtle information is nuclear fuels. Often developers or technology enthusiasts will talk about uranium oxide fuels, Trisol fuels, metallic fuels, accident tolerant fuels, molten salt fuels. I could probably bore you for the next half hour with different technology and fuel types. But the key is, if you hear one of these terms, it also carries a lot of implications and give you a lot of information about technology before you even start the conversation. So each fuel type is going to have different advantages and compatibility with different reactor types. And so one example that we can kind of dive into to get some of these insights is Trisol Fuel. Now, for anyone that's not familiar with Trisol Fuel, it's a really exciting fuel concept because it's a fuel with its own containment. And the idea is that the design of a Trisol fuel particle allows it to more fully contain any type of radioactive fission products that would be created during operation. The way you can think of a Trisol fuel is it's actually a small pinpoint of uranium surrounded by different layers of carbon that basically form a poppy seed of nuclear fuel. These particles can then be put in forms like graphite pebbles or in prismatic blocks to actually fuel the reactor. And so when you just think about this concept of, okay, we have a Trisol fuel particle, so what? Well, the advantages are these layers of carbon that surround the uranium can actually help prevent or limit the release of radioactive material and eliminate the need to have some of the safety systems that you might traditionally see or rely upon with other reactor technologies. Additionally, Trisol fuel is going to be stable to very high temperatures, so the traditional concerns about a fuel meltdown might not occur just due to the ability to actually remove the heat from the reactor fuel itself. And finally, Trisol fuel is expected to be very proliferation resistant and especially hard to divert to military uses, just due to the actual physical design of the fuel itself. And so this could contrast with other fuel forms that might require more programmatic or design controls to limit proliferation risks. Again, these are a lot of insights you can get just by learning that the fuel form is Trisol. And so the primer goes into the different fuel forms that we expect to see in advanced reactors. So you can gain a lot of these insights as part of your background research, or even to help kind of support just ongoing discussions about advanced reactors in general. The final thing that I kind of want to highlight that's really interesting within the primer is the idea of how the actual use cases of advanced reactors could differ from conventional nuclear that we think of. Normally, when people talk about nuclear technology in the United States or historical nuclear technology, people think of large base load electric generating nuclear power plants that have reliably served the grid for the last 5 to 6 decades. But advanced reactors are going to have some technological differences that might open up new use cases or new markets that could be potentially interesting in the future. Some examples might include being able to utilize higher operating temperatures by looking at new materials, new coolants, and new fuels that could facilitate the integration of advanced nuclear energy into process heat applications, for example. That's a market that historically hasn't been open to hasn't been historically open to nuclear technology, but might be open to advanced nuclear. Advanced reactor developers like the ones we have here today are investigating a wide range of reactor sizes, power outputs, and modularity options that might open up different industries and siting opportunities. The advanced reactors that we might see in the next decade and 2 decades might not necessarily be these large baseload electric generating units that we're used to. And finally, the idea of advanced microreactors and remote applications could really revolutionize the way we think about low carbon electrification of remote locations that have substantial electricity demands. Off-grid operation of nuclear energy eliminates many of the challenges associated with routine fuel transportation that we might see for technologies such as diesel generators or site-dependent energy resource availability, such as renewables. And so the primer goes through all of these different use cases for advanced reactors and discusses some of the potential opportunities and potential limitations. We really hope that the primer can be a valuable tool for the non-nuclear expert, and can help journalists like yourselves report on energy, climate, and technology. And finally, just kind of in addition to these different technology independent aspects, we also do descriptions of the different advanced reactor vendors. So you can get an idea of, oh, what are the different combinations of fuel, technology, and use cases that vendors are currently thinking of. And so this can be a way to help kind of inform what does a whole space of advanced reactors look like. So wrapping up, because I know I've been talking about advanced reactor technology for a while, even with these 3 brief examples. The primer is just kind of one example of the type of educational tools that NIA has published on advanced nuclear energy. All of the resources that we have speak to the idea that NIA can really serve as kind of a credible expert source for policy analysis and technical support in the field of advanced nuclear energy. So as you interact with the primer, hopefully it's live now on our website, and I believe everyone on the call has already gotten their advanced copies. We hope you'll continue to look to us as a resource to help you understand the technologies and help connect you with key industry leaders that can provide even more detailed information on where they're looking at taking their technology, such as the 2 developers that we're very excited to have speaking with us today. And so with that, I will turn it back to Ben.
Thank you so much, Dr. White. I'm hoping for all of you on the line, you can already see how useful this primer is going to be for your ongoing coverage of this industry. But don't take our word for it, and here comes the flowery introductions. I want to get now to the 2 leading developers we've invited to join us. We're going to hear what they have to say and what they have to share, not just about the primer, but about their businesses and how they see the advanced nuclear marketplace shaping up in the years ahead. So we're going to start with Harlan Bowers, the program manager for the XE Mobile business at X Energy, which is the company's transportable nuclear power source for military, remote community, and disaster relief applications, sort of building on what we just heard from Patrick. And Harlan has 25 years of experience managing multi-million-dollar programs and an impressive track record of development at X Energy. He joined X Energy in 2015 from Stinger Ghaffarian Technologies, where he led business development and several NASA engineering service contracts. Prior to that, he was in several director-level roles at Orbital Sciences Corporation. And he earned a Bachelor of Science degree in Aerospace and Ocean Engineering, which sounds really cool, from Virginia Tech, and an MBA from the University of Maryland at College Park. So Harlan, welcome again. The floor is yours.
Thank you very much, Ben. It is nice to know. I am an aerospace engineer by background, and I continue to, even though I started in 2015, I consider myself to still be drinking from a fire hose when it comes to understanding the nuclear industry. So again, thank you for the opportunity to do this primer. X Energy has been in business since 2009. It was not formed as a nuclear company. It was formed as a company to do something different in the energy space, something non-fossil fuel, safe, clean, proliferation resistant. We ended up choosing in 2011 the high temperature gas reactor technology in order to achieve these goals. But at the end of the day, it is the customer and the application that will drive whether the technology is the right one to apply. So while we like Trisol Fuel and we like HTGRs, that may not be the best answer in every single case. Our business is broken into three primary areas, and I'll highlight what our current major endeavors are in each of these areas. First is commercial reactor applications. As Patrick had alluded to, grid scale, large electricity production applications. And here we lead with a product called our XE100, a modular 80 megawatt electric pebble bed high temperature gas cool reactor. And you can configure this reactor into power plants that use up to 8 modules. So you're generating up to 640 megawatts of electricity. Not only are we looking at electricity, but again, as Patrick had alluded to, there are opportunities for large scale production manufacturing capabilities, as well as industrial process, high temperature, high pressure steam applications using variants of the XE100. Our flagship program right now is a contract that we were awarded, I'll say a cooperative agreement that we are awarded with the Department of Energy. It's called the Advanced Reactor Demonstration Program, or ARDP. And for X-Energy, it was a $2.4 billion program to design an XE100 based nuclear power plant, to do the construction and commission that nuclear power plant to operate in the state of Washington with Energy Northwest as the operator. Our focus from a market perspective is on the US, Canada, and UK. All three are leaders in advanced reactor technology and taking the first steps forward to establish demonstration reactors in their locations. The second area is fuel. And so over the past 6 years, we've invested tens of millions of dollars to understand what the original developers of Trisol Fuel or ceramic coated fuel were trying to accomplish. So going back to first principles to understand manufacturing techniques and characterization techniques so that we can make higher quality Trisol-based fuel with less defect fractions in that production. Our commercial fuel fab facility will be in Oak Ridge, Tennessee. We'll be submitting our application for construction to the NRC later this year, and that plant will be in place and producing ton scale of Trisol fuel particles and fuel forms by 2025. Finally, it's our government research and development business. And this is really looking at government-driven applications for nuclear technology. And the best example of that for us is the Department of Defense and their what's referred to as the Pele program. This is a microreactor, transportable, able to be set up in 3 days to provide electricity for more than 3 years, and then to have the ability to shut the system down, pack it up, and be ready to ship out in 7 days. It also needs to be compatible with flights on a C-17. There are other applications for microreactors as well. Space nuclear is currently a very hot area, whether it's nuclear thermal propulsion, fission surface power. These are all enabling technologies to allow the manned space exploration to continue forward. And there's also been a lot of interest in emergency response applications for deployable transportable reactors, as well as marine applications, putting these into cargo ships or providing power to ports where you've got a ship that can bring that capability in. Let's stop there. Those are the areas that X-Energy is currently focused on. And thank you very much for the opportunity.
Well, thank you, Harlan. It's so helpful to hear about what's actually happening in the marketplace and also dates and years and milestones. So, learning about how companies like yours are working to commercialize advanced nuclear technologies is really helpful. So now we're going to hear from our other special guest and another great flowery introduction. We're going to hear from Dr. Christian Rabidi, the Director of Technology Strategy at USNC. And in this role, he is focused on developing the US market for the company's micro-modular reactor technology, including modeling and simulation to support the licensing process, always a very important part of this conversation. Prior to joining USNC, Dr. Rabidi worked at Idaho National Laboratory, where he led the development and application of tools for, and I'm going to quote this because I don't know what it is, techno-economic analysis of integrated energy systems. Okay, wow. Prior to that, he was a software developer at Argonne National Laboratory, and Dr. Rabidi received a PhD in mechanical engineering from the University of Stuttgart in Germany, and an executive MBA from the IE Business School in Madrid, Spain. Wow, what a great background. Christian, we're so glad to have you with us, and what can you share with us today?
Well, first of all, thank you for inviting USNC to the presentation of the primer, which I really believe that is going to be a very nice tool to have in our hands for the communication with the stakeholders in understanding the technology, the nuclear technology overall, and especially the advantages that advanced nuclear may have in fighting the CO2 and the climate change. USNC. Somehow we still refer to USNC as a startup, but we are more than 140 people actually working in the company. In August 2011, it was this August was essentially our 10th anniversary of the foundation of the company. So we are getting old in some sense, which is good because we're maturing, and along with the company, also the products that we are commercializing are also maturing. So I have to say that Patrick and Harlan, they already spoke a lot about high temperature gas reactor technology. So USNC has a high temperature gas reactor. It's a micro reactor. So the reactor, actually, we'll look at it as a fission battery. So the concept is that actually it doesn't need to be refueled for a very long time. Depending how much energy you want to extract from this reactor, from this unit, it's going to last maybe 20 years, maybe more. So it is really about the amount of energy that is encased in the core. And so this is kind of our business model. We produce, and we sell a unit that supplies heat, energy for a very long time. Our unit currently, which, by the way, we are planning to deploy the first unit in Canada at the Chalk River site. It is planned to be online in 2026, so a very short timeline. It is a 15 megawatt thermal reactor, which is going to last for 20 years without refueling. So if you use less power, the reactor is going to last longer. So this characteristic of our value proposition make it a good blend for variable renewable. So now we have a reactor that is not anymore a base load, but is something that can play along and help the variable renewable to stabilize the grid. So this is the way in which we look to our technology. In the US, I think that it was in the news not long time ago that University of Illinois submitted a letter of intent to the NRC for the licensing of the reactor in the US. I think that, we spoke a lot about the technology around ATGR. So there is not much more that I want to cover with respect to technology, aside the fact that we have taken, a little bit different choice in the fuel. It is still Trisol Fuel, but our fuel is encased in silicon carbide. So we have pellets which they contain these small seeds like poppy seed kind of size, which are the Trisol. Inside those pellets, the Trisol are surrounded by silicon carbide, and I have to Google it. It is like the third most hard material in the world that is known. So this is the light water reactor, they have served it very well for a long time, but the technology has evolved a lot. And now that the nuclear is needed again to help to fight the climate change, there was a lot of technology development that we can actually harvest. And these new advanced reactors are the product of this harvesting. The company has two lines of products. One is the micromodular reactor that I just spoke about. Plus, we have also a section of the company, Usnc Tech, that is focused instead in space application, so nuclear thermal propulsion and also remote heat for space application. The company headquarters are based in Seattle, and for the project in Canada, we have actually a joint venture with OPG, Ontario Power Generation. So the company is actually present pretty much all over the world. I think we have two main projects right now, which we're working on. And the fact that we have a deadline in 2026, to me, tells also the fact that, I heard a lot, nuclear advanced technology is going to be difficult for this technology to be part of the fight against the climate change, because we are not going to be ready in time. We're not going to be there in time. I think we can. And, the fact that we have this very early deployment essentially says that if the market is ready, if they're the right, if we make the right value position, I think we can play a big role in this. Thank you.
Thank you so much, Christian. An excellent point about being ready for 2035 and the other milestones to come. So thank you so much. And thank you, Judy and Patrick and Harlan. As a reminder, reporters on the line, if you have a question for one or more or all of our panelists, please put it in the chat now, as Dan has done, or in the Q&A box, as Lisa has done. Or you can raise your hand to let us know that we should turn on your mic and you can ask the question live. I'm going to skip the questions we wrote ahead of time because we do have two questions to start with, which is terrific. So I'm going to start there. We have a question on HALEU fuels from Dan Yerman of Neutron Bytes. And his question is, while DOE is working on pilot projects to fabricate HALEU fuels, U-235 equals 5 to 19%, developers of advanced reactors worry that commercial quantities may not be available in time for them to bring their technologies to market. Fuel developers worry that they may wind up building fuel fabrication plants ahead of the market and not have revenues to justify these investments. How do you see these chicken and egg issues, and are there solutions to get markets and demand in sync? So who'd like to go first? That's a good question.
I would love to go first if I may. I'll say, Dan, you speared directly into the heart of our risk mitigation plans. As we look at our projects and we look for what are the highest risks, availability of HALEU or high assay, low enriched uranium is a key risk that we're working to manage. And while we're looking at something as small as a microreactor, where only maybe it's a couple hundred kilograms of U that's required, down blending from HEU for a government program is a possibility, but for a commercial program, it is not possible. For a large reactor that requires tons of HALEU, that is not a viable option. We have surveyed, the world, and the viable option in the near term is to buy HALEU from the Russians, and so that is being evaluated. There is, as you have noted, there's ongoing discussions with the three enrichers in the United States, Centrus, Urenco, and Orano, to see what would be required to provide the appropriate market signal for them to make the necessary investments. But the answer to your question is near term, the Russians, longer term, US enrichment solution.
Harlan, thank you. Christian, do you want to reply as well?
I think that Harlan said it all. There is not really much more to add. And, and I think that the DOE is really committing, to make it happen. So that is the situation where we are now. And I think that it's going to be resolved. I'm optimistic.
Great. Thank you.
Judy, Ben, if I can jump in. Yeah.
Go for it.
Yeah, so I think one important kind of nuance in this discussion is to really break up the idea of the HALEU fuel cycle into two kind of discrete pieces. The first piece is how are we actually getting this HALEU material, this high assay, low enriched uranium material, from different vendors, such as Harlan described. And then what our developer is going to do to actually try to take that material and turn it into the fuel that they're going to need to power their first, second, and hopefully third, fourth, fifth generations of reactors that they're deploying. And so I think it does become kind of an interesting chicken and the egg, where the developer doesn't want to make the investment in the fuel fabrication facility that you discussed in your question before they actually know the material is existing. And the developer or the enrichers and the people that are HALEU kind of stock material don't want to spend the money needed to create that stock until they know the factories are ready. And so, as you alluded to, it's a really interesting chicken and the egg. And I think this is a place where looking kind of at the supply side of how we're actually creating this HALEU material can be really powerful. It's not something where we're necessarily looking to a specific advanced reactor developer, but in fact, it's more of kind of a common resource that all advanced reactors are going to need. And so I think there's a lot of really interesting discussion ongoing right now about how can we kind of create these marketplace solutions? What types of incentives will get us to a healthy functioning commercial marketplace that aren't necessarily just the federal government downblending existing stocks of highly enriched uranium into this high assay, low enriched uranium. And happy to go into the technical details on those if people are interested.
Thank you, Patrick and Harlan and Christian.
Yeah, actually, Ben, I just want to make one comment to sort of put this in the broader climate and energy solutions context. So we're going to need both public and private action to get over this chicken and egg problem. And this is actually something that happens in a lot of the decarbonization technologies. If you think about, for example, electric vehicles, it's both an issue for the vehicles as well as making sure that we get charging infrastructure. And you need private investment, you also need public policy, you need partnerships. So this is an area where we need both the federal government in particular, as well as the companies, both the developers and the fuel suppliers, to all work together to figure out how to jumpstart this and make it work over time as a market-based solution.
Excellent points. And Dan, if we didn't address everything that you asked, you're welcome to type a follow-up in the box, or we will open this up to live conversation as well when we're done with our questions. So you can certainly follow up. But I do want to make sure we address great questions coming in. So the next one is from Lisa Martine Jenkins of Morning Consult. And she asks, of the various reactor fuel types, which combination is closest to commercialization? Which do you expect to have the widest applications in the US power sector? So who wants to go first?
I'll let you go first this time.
I'm not sure. Yeah, sure. I'm not sure I understood exactly the question. By the power sector, because, okay, we have the grid, electricity, and we have heat, right? These are both power sector, right? And something that we said about this technology is the higher temperature. So we think that the higher temperature can actually open the market for decarbonization of the industry broader rather than just to the grid itself. And also we should keep in mind that a lot of energy and electricity is created behind the grid right now, and this is a problem because if you decarbonize the grid, you do not decarbonize the industry. So I think that a combination of electricity, heat could be the range of application. The business of our company, though, is a little bit different in the sense that, as I said, we put out a battery with a certain amount of energy, and we can work with the customer to specialize the way in which you use it. But we always start from the concept, hey, here it is, an X amount of megawatt hour that you can use over the next 20, 30 years. And so depending what is really the customer need, you can work it together.
Ben, if you allow me to answer the question a different way.
Sure.
So the first question was that I can recall was quickest to market, and so let's look at the advanced reactors. We've got molten salt reactors, we've got fast reactors, we've got high temperature gas reactors. In rough terms, the Department of Energy has invested on the order of $500 million in the development, manufacturing, characterization of Trisol fuel, tristructural isotropic fuel. And the program that they ran that under was called the Advanced Gas Reactor Program, AGR. And through that program, they've answered a lot of the questions that the regulator would have. And so the answer is whatever is quickest to market is what is going to get through the NRC with the least number of scars. And I would venture that the Trisol Fuel, because of that investment and the amount of time DOE spent working with the NRC, will be the first one through. And there are a number of advanced reactors that use Trisol Fuel as their base. Not just Christian and myself, but Kairos is another example. And so those have an inherent advantage at being able to get through the regulator the fastest, my opinion.
Thank you. Patrick or Judy, do you want to chime in before we move on to the other questions?
Yeah, I think I'll just say that I'm not sure what's going to win. I think that we have a really amazing portfolio of technologies that different developers are developing, and we're in a bit of a race. And it's both who can get to market fastest and also who can get to market effectively and with good business models and customers. And we're seeing multiple reactor companies and designs sort of in this race. And it's a really very exciting moment to be in this space and to even just to watch this space. So I at least am keeping open about who's going to win, but are watching very carefully a number of these designs. And really, I'm very excited about the portfolio that we've got going in this country.
Thank you.
Yeah, the one thing I'll add is I was debating which metaphor to use, if it's either trying to gaze into a crystal ball or pick the favorite of your children. But I think when you take a look at the advanced reactor technologies that are out there, all of them are going to come with kind of unique advantages and what they're kind of bringing to the marketplace and what they're looking at in terms of commercialization timelines. I do think that the U.S. Department of Energy investments in the ARDP program were in gas reactor technology and in sodium reactor technology. And so I think those you might be able to kind of at a first cut say those maybe are the most mature technologies just based on historic operating experience. We have operated those technologies before. And so they definitely have a leg up in terms of they have a head start in the race, I guess is more the appropriate metaphor to use in terms of commercialization. But I think like Judy said, there are a lot of really, really interesting technologies out there. And a lot of this is going to come down to project execution, not necessarily who has the best combination of fuel and coolant, but who has the right staff, the right business model, and the right design that really enable that it's a product that people are going to want to have and that companies are going to be looking to build in the future.
Thank you so much. And I should point out that Lisa did chime in the chat box to say that she did mean the electricity sector. So Christian, you were correct in addressing that part of it in your answer. So just to clarify that Lisa did say that. So a couple more questions here. The first one, we have two from Debbie Carlson. And the first one is, you mentioned greater interest from investors. On the sustainability and ESG front, nuclear energy is still seen negatively. Where is this investment interest coming from? So who'd like to do that first?
So actually, I'll let the companies go first.
Yeah, well, I don't know how much of this I can go into. I'll start by saying it still boggles my mind the amount of investor funding that's going into fusion technologies. And I think if the fusion guys can get investor, why can't the fission guys get investors? And the answer is we can. And so we very recently closed out a B round of investment. I can't go into specifics on that, though I can say that more than $100 million has been raised in that B round, which I think demonstrates that the business model that we're moving forward and the opportunities that are created by ARDP as well as Ontario Power Generation make enough of a compelling case that advanced nuclear is an investable technology.
I mean, definitely, I agree with what Harlan said in the sense that, we want to decarbonize industry and electricity production. At that point, I think that a lot of options, they become open. It's going to be expensive in the sense that, you think about variable renewable and battery only, they're going to create, the jury is out in the sense that we don't have a winner in terms of what is going to be the technology that is going to bring us to net zero. So I think that, advanced nuclear reactor most likely is going to be part of the solution. So I don't see why the investment should not be coming in our direction.
Judy, I think you wanted to chime in as well.
Yeah, I'll echo that. You know, the companies, this information about who's investing is it's often a confidential business information, but we are definitely seeing interest from everything from venture capital to large companies who have and maybe an advanced reactor division or people working on the whole fuel cycle chain. So we're seeing lots of different types of investors. And I think the questioner is correct that really advanced nuclear should be of interest to investors who are interested in sustainable investing. And I think one of the things that we have to do a better job at is educating people about the sustainability benefits of advanced reactors. I think that often it's not well known about nuclear's low land use. They don't take up a lot of space. The reactors, we are very good at dealing with the whole fuel cycle and with the reactors themselves. And so I think there's a lot of benefits that just have to be articulated better and people have to be educated about it. And I think that will generate additional interest from those who are interested in climate solutions. We certainly are seeing a lot of interest from utilities who know that they have to decarbonize and think that they have some ideas about how they can get to decarbonization, but they have gaps. And they're very excited about the potential for advanced reactors to help them meet their decarbonization goals.
Well, speaking of education, someone should do a primer. Oh, wait, never mind. So another question from Debbie, just sort of building on that, and it follows nicely from what you were just talking about, Judy. Can someone address the issue of waste? I know Christian says the reactor in Canada can be fueled once in 20 years. However, dealing with nuclear waste has always been a deal breaker for many sustainability investors. Can you address these concerns? Christian, do you want to start since she referred to your point there?
Yeah, definitely. There is still, a few question marks opening there. Now, I want to point out that with the choice that we have made in the type of fuel, we are trying to take a very conservative path also with respect to the waste. Our Trisol Fuel, it is encased in silicon carbide, which creates a barrier, an engineering barrier for release of radioisotope. So how to say, there is yet not a final decision on the waste in the US, but at the same time, I think that also the new advanced type of fuels, they may help and ease that burden. So that is where we are now, I think.
I'll add that we're all frustrated with Yucca Mountain and whatever comes after Yucca Mountain as a long-term depository. Canada is working on their own solution and are committed to putting that in place. The challenge with ceramic coated fuel is that it is really hard to break it down. And to Patrick's earlier comment, proliferation resistance is important, but it also means that the volume of material that needs to go into long-term storage, depending on how you measure it, could be a bit more than you might see with light water reactors. But to Christian's point, encapsulated in silicon carbide or encapsulated in carbon, these are excellent long-term storage packages that don't rust, they don't break down, they will be no different 200,000 years from now than they are today, and therefore are a good long-term package for the deposition.
Thank you both. Patrick or Judy, do you want to add anything?
Yeah, definitely. So I think one thing that's really important is kind of thinking holistically and contextualizing the discussion around nuclear waste. And it is a problem where in the United States, it's not a good history. You have legacy from the Manhattan Project and the US nuclear weapons sector, which gets blurred in with commercial civilian nuclear power. You have issues related to the federal government's promise and then failure to actually deliver on spent nuclear fuel storage or nuclear waste repositories. And all these have led to just lots of frustration from communities and from different stakeholders. And so I think looking forward, there are a couple of important things to think about. The first is to actually just think about the process in general. When we talk about nuclear waste and nuclear waste storage going forward, forcing someone to take it in their backyard is not the right approach to sustainability, and it's not the right approach to a sensible society. So looking at processes like consent-based waste storage and looking to work with communities to try to host repositories instead of forcing them on communities might be a better way to kind of change the conversation and move this away from a burden as something as a community is willing to accept and willing in exchange for essentially the societal benefits that would come along with it. The idea of increased funding, the idea of good jobs, things along those lines. I think another kind of really big thing to keep in mind is even just relative hazards. When we talk about life cycle analysis of all technologies, they're going to have impacts, whether it's mining the rare earth metals that might be required for renewable energy resources, or even the front end and the back end of the advanced nuclear fuel cycle. Everything that we do is going to have an impact on society and going to have an impact on the environment. And so I think the thing that we need to do is kind of think on a very, very broad level of how are we dealing with these hazards and how can we best control them. There are a lot of different new technological approaches to trying to deal with spent nuclear fuel, whether it's long-term geologic disposal, whether it's things like deep boreholes, or maybe it's even opening up the idea of reprocessing to try to reduce the volumes and change the way we think about advanced fuels. There are a lot of different options out there, but I think it really first starts with better engaging with society so we can have a discussion about what we're going to do with this waste rather than saying it's a problem, it's going to be a problem, and it's a big problem. When in reality, it is something I think that's manageable.
Thank you. Judy.
I mostly was going to say some of the things Patrick said, so that's great. Let me just emphasize one point, which is that to have the kind of society that we want to have with the way we live, the way we want to live, everything from having medical technology to homes and the way that we, all of the benefits that we get from modern society, we need materials and we need energy. And if you look at nuclear power on a life cycle basis, it really does perform quite well on those fronts. And so that's really important, that it's not that we're going to be able to do what we want to do as a society without materials or energy. And once you admit that we need materials, energy, nuclear power looks, particularly these advanced reactors, looks very promising and exciting.
Thank you. So we have one other question, which Harlan's already partially answered, but I want to put it out there in case anyone else wants to address it. So Dan Yerman asked again if we could identify the Russian fuel fabrication plant that can supply HALEU. And Harlan answered that it's TENEX, T-E-N-E-X. But Dan also asked, is it online and ready to supply fuel, or what is the timeline for production?
It is a state-owned capability. And so TENEX is responsible for supplying Russians' nuclear requirements as well as commercial requirements. I can say that in our conversations with TENEX, their answer has been, how many tons? Tell me what day you want it delivered, and tell me what enrichment and format you want it in. You want it in oxide or you want it in metal? They have the capability to provide it today.
Good, thank you. So I would like to just quickly open up the mics, Alex, if that's possible, to see if anyone has any follow-up. I know Dan's asked a couple questions. Debbie has, Lisa has as well. Do any of you want to follow up live and in person before we go on to a few other questions and then wrap things up? Going once. You're welcome to just, your mics should be open, so you're welcome to just start speaking if you do have a question. Debbie or Lisa or Dan or anyone else. Robert? Looks like folks are saying they're good. So Alex, you can close the mics back. If you do change your mind, just stick it in the chat. I did have just two questions to use for wrap up. And for Judy and probably Patrick together, since the primer is your product, what's the #1 message you want reporters to take away from this conversation about the future of the advanced nuclear industry?
Yeah, so I think what I started to say earlier, and I'll just reemphasize, is that this is a really exciting and dynamic space. And I think it's a bit complicated to people who don't know much about it. And we really hope that this will demystify the space a bit and help people to understand how exciting this is. It is absolutely critical that we develop these advanced reactors to help us solve the climate problem. And the fact that we have all of these developers working on it and there's all these different technologies is very important. And it's important to have, what we do, which is an independent source of information so that you can judge what you're hearing from individual companies. All the companies that we know of are very enthusiastic about their own technologies, and we are enthusiastic across the board. But to really understand who's doing what the risks and benefits are of the different options, we really hope that this will help you get started down that path.
Excellent. Patrick.
Yeah, thanks. Yeah, so I think for me, it's when you just look at the history of nuclear energy, it was always kind of shrouded in secrecy from the beginning. And as we look towards these advanced nuclear reactors, it's an opportunity to really be clear and transparent with society of the advantages that these reactors might be able to bring, and then also allow them to learn more about the technology and ask very legitimate questions about it. And so for something that can be as complicated and as complex as nuclear energy, we're just really, really excited to say, what are the resources that you have available? So you can not only hear the claims that developers and companies, advocates and opponents are all making, but then critically evaluate them yourselves. And specifically for journalists, give you the information, the tools you need to make those critical evaluations. So I know we're really excited about nuclear energy, and we're really happy to discuss any of the technical details to really help you along your pathway of communicating these important issues.
Thank you. One final question, and then we will wrap up because we do need to make sure we end on time. This is from Robert Bryce. What about China and Russia? Russia has already deployed a power ship with an SMR. Might they beat US companies to market in this space? Anyone want to tackle that quickly before we wrap up?
Well, just to say that, of course, we are aware of new technology and this state-owned company that are putting out these new reactors. That's part of the game in the sense that, we watched them, we are aware of their technology, and we still believe that, as I think was mentioned before, it's a mixture of technology and operation in the sense of being capable to deploy cheaply the product that you have. So we believe that we can win on the market.
Thank you. Harlan.
I'll just add that in the commercial space, it is possible that they might beat U.S. companies to the market, but there are applications such as the Coast Guard, there are applications of DoD, Navy, cargo ships, and I'm pretty sure they won't buy reactors from Russia.
Judy,
I know you have some thoughts on this. I'm going to give you the last word.
Yeah, I do think that these state-owned enterprises do have some important advantages, and the U.S. nuclear industry has, for the past decade or so, actually a little bit longer, gotten behind in terms of deployment of new reactors. But I really think it's a new day now, and I think that the U.S. companies, that the sort of partnership between the federal government and this new generation of advanced reactor developers is something that we're particularly good at in the United States. So I also am optimistic that between this suite of developers who are working and sort of bringing their entrepreneurial and spirit and technical know-how, and the US government being supportive in terms of bringing demonstrations, funding to the table in a public-private partnership, working on all these fuels issues, and making sure that we have a platform for the companies to succeed, but it's really private sector led. I think that we really are well positioned to sort of get our groove back on this. And I think that advanced reactor developers have a great potential future. Of course, that there's no certainty in this kind of game. Innovation is really cool and exciting, but it's hard. But I think that there's lots of reason for optimism that we actually can be a global leader in advanced nuclear technology.
Well, thank you so much, Judy. An hour goes by very quickly on Zoom. Maybe that's just me. In any event, we're almost out of time. Please join me in thanking our terrific panelists for sharing their insight today, Dr. Christian Rabidi, Harlan Bowers, and NIA's Judy Greenwald and Dr. Patrick White. You should have all received a copy of the primer already, but if you didn't, you can download it from the NIA website, which I've put in the chat box. It is www.nuclearinnovationalliance.org. If you have additional questions or you just want to confirm a detail or a data point, get in touch with me, Ben, at renewpr.com, and I'll follow up. And thank you all so much for joining us today and for your interest in learning more about advanced nuclear technologies. We hope to see you on future webinars as we roll out new products. And if you want to make sure that you receive invitations and updates from us, email me, ben@renewpr.com, and I'll be sure you're on our press list. For now, have a great day. Thanks again for joining us.
Thank you.